let's take a typical example. Okay, let's take LDL. Doctor says you have high LDL. They say that's the disease. Here's the treatment for it, a statin.
Yeah,
Garbage. Okay,
yeah.
total garbage. The fact of the matter is, if you look at the statin literature, which we did, 44 studies in the meta-analyses, the Cochrane group, and bottom line, for primary prevention, if you take a statin, you will increase your lifespan by 4 days.
Yeah, but 4 days could be a lot. You know, you can do a lot in 4 days. Right?
I suppose
Isn't it worth
so.
the trillions of dollars? It's worth $1 trillion.
I guess the question is, since 20% of people who go on statins develop diabetes, and yet another 10% have rhabdomyolysis and other problems related to the statins, is that a good trade? The bottom line is, the doctor will tell you, oh, you have high LDL, here's the treatment. Garbage. Okay. The high LDL is a symptom of the problem, not the problem itself. Same for high blood glucose. So you have high blood glucose. The doctor gives you, sulfonylurea or glutamide or whatever, to lower your blood glucose, and it will lower your blood glucose. The point is, the high blood glucose was actually a manifestation of the mitochondrial dysfunction. You haven't done anything for that. Yeah. And the bottom line is, all of these medicines are treating the symptoms. They're basically salutary. They're not actually dealing with the problem. It's like giving an aspirin to a patient with a brain tumor because they have a headache. Might help the headache, ain't going to do a damn thing for the brain tumor. Yeah. And that's the way modern medicine has been dealing with all of these problems until you get to root cause. And Mark, I know that is like the two words that put your hair on fire as a functional medicine doctor. I got it. Those are the words. Root cause. Okay, you got to fix the problem. You don't fix the symptom of the problem. As I say in the book, you go up into your attic and you find a wasp buzzing around your attic. What are you going to do? You're going to kill the wasp, or are you going to find the wasp's nest? All right? Exactly. Where there's one wasp, there's many wasps. All right? Yeah. You got to fix the problem, not the result. You got to fix the problem, not the symptom. All right.
And you say these diseases are not druggable. That's an interesting concept. They're not druggable. You may modify the symptoms, but they continue to progress. They continue to get worse, and you continue to die from them. It might be a little slower. You might slow the rate of it. You might improve it a little bit, but they're really not fixing the problem.
Right. Well, in the case of the high blood glucose, it's not the glucose that's causing the problem. It's the insulin. The insulin's actually driving all the chronic metabolic disease, not the glucose. And I can prove that too. Okay, there's a mouse, my favorite mouse. Can we talk about mice for a minute?
Sure.
You okay? Talking about mice? Okay, my favorite mouse in the entire world. Okay, it's called the Podurko mouse, the glomerular podocyte insulin receptor knockout mouse. Okay, so this mouse is missing.
Whatever that means, but okay.
This mouse doesn't have the insulin receptor in his kidney. Okay, it's been lifted out genetically. All right. This animal has normal blood glucoses. This animal has normal glucose tolerances. This animal has the worst diabetic kidney disease of any animal model on the planet.
Wow.
Why? Blood glucoses are normal. Everyone says, oh, it's the glucose that's causing the kidney disease. Garbage. It's the insulin that's causing the kidney disease. And we know that because the type 1 diabetics, they have high blood glucoses, but their kidneys don't get shot for 30 years. The type 2 diabetics, their kidneys are shot before they even walk in the door.
Yeah.
Because they have high insulins, because it's the insulin that's the problem, and we're not touching that.
This is really important. And I one of the things that really woke me up to this was this big study of 10,000 diabetics called the Accord study. You remember the study from a long time ago. And the idea was, let's aggressively lower blood sugar in order to improve outcomes, reduce deaths and kidney failure and all the complications of diabetes.
And it increased the deaths.
Yeah. So actually it was fascinating because the more insulin you gave, the more drugs like the oral hypoglycemics you mentioned, the sulfonylureas, they work by increasing insulin, which is like flogging a tired horse. And they produce more insulin. And the more insulin you give, the worse the outcomes. So this was just a fascinating study. better glucose control, more deaths, and more complications.
There are actually 5 studies that have shown the same thing. That's Accord's one of them, but the advanced study showed it. The ADVT trials showed it. The miraglitazar study showed it. The UKPDS study showed it. The bottom line is more insulin, more death.
Yeah. And yet we continue to do the same thing in medicine over and over, despite all the research. We say we practice evidence-based medicine, but we really don't. We ignore the evidence that isn't actually fostering an increase in the sale of drugs and medical procedures. It's just all the incentives are so backwards.
Bottom line is Einstein's theory of insanity is rife within medicine, and he famously said, doing the same thing over and over again and expecting a different result. Well, we've been doing the same thing over and over again for the last 50 years. And you know what? No different result.
So you frame all these diseases as really the tip of the iceberg. And underneath it, you say, are these 8 processes, these 8 metabolic phenomena, these subcellular pathologies, you call them, that are really driving everything. And I'll just list them, and then we can kind of go into them all. We talked a little bit about insulin resistance, but glycation, oxidative stress, mitochondrial dysfunction, we've touched on this, membrane integrity, inflammation, epigenetics, autophagy. You talk a lot about this in the book. It's a lot of big words, but it's actually a lot of the same topics that I wrote about in my book, Young Forever, because it all drives chronic disease, all drives aging. And they're underneath, these are also known as the hallmarks of aging, which are the phenomena that happen that are driving the disease. So hallmarks actually are upstream, and they're not symptoms. They're basically these phenomena that happen from different insults, mostly from food, by the way. We'll talk about how to fix them with food, and you kind of break it down. I was just like jumping up and down when I saw it. I was like, wow, this is it. You got it. So tell us about these 8 processes and how they lead to all these diseases.
Exactly. So these 8 processes are, for the most part, not processes that you can sort of test for. They're happening in the cell. Okay. There are ways to do it. I mean, researchers can do it, but they're not, shall we say, clinically available. But they're going on. Yeah. They're going on in all of us. It is part of life. All of these are part of life. You can't stop them, but you can slow them down. But you can only slow them down with food. All right.
So they're foodable.
They're all foodable. Right. Exactly. Not druggable, all foodable. All right. Example, glycation. So glycation, a glucose binds to a protein. Now, when it does that, it makes that protein less flexible. It makes that protein end up being recycled. Okay. It might change the function of that protein. It might cause that cell to become more fragile and friable, and might end up causing cell death. Okay, so glycation is not a good thing. Now, this is what diabetics measure when they measure hemoglobin A1C. This is glycated hemoglobin, the glucose binding to the hemoglobin molecule. Well, that's happening all over your body. It's happening all of the time.
Yeah.
Right? The question is how much? Right? It is the cause of wrinkles. It is the cause of cataracts. Right?
Yeah.
The cause of cardiovascular disease inside
dementia.
the blood vessels. It's one of the causes of dementia, not the only one. But it's the bottom line is you don't want to be glycating. All right. Now you're going to be glycating because it is a process you can't stop. Okay. It is part of life, but you can slow it down. How do you slow it down? Stop providing the substrate. Okay. And the substrate for glycation are 2. Glucose. Yes. But fructose is 7 times worse. So both do it. But fructose does it 7 times faster and releases 100 times the number of oxygen radicals, which we'll get to in number 2. So
and that's why high fructose corn syrup and everything is super bad, right? Extra fructose.
Yeah, but there's fructose and sucrose too. I mean, so it almost doesn't matter. The point is, sugar's a bad guy in the story. Okay, full stop. That's what we don't tell our patients, and that's the thing that they need to watch, and it's the thing that they can control themselves if they choose to. So that's number 1. Number 2, oxidative stress. Those little hydrogen peroxides. Now, hydrogen peroxide is good if you have a wound, but it's not good if it's inside the cell. right? Because those hydrogen
Unless you
peroxides,
want to kill an infection or cancer or something, then it can be good. But you know, your body makes a little bit, but it shouldn't make too much.
right? But you shouldn't be making it in your liver, right?
No.
Well, every time a hydrogen peroxide gets made, okay, it's doing damage. It's doing damage to a lipid. It's doing damage to a protein. Ultimately, it will kill cells. The bottom line is oxidative stress occurs every time that glycation reaction occurs. Now, it also occurs from iron. It also occurs from various other processes that go on in the body. But the sum total of that oxidative stress is the aging reaction. That is what aging is. And so we need to basically try to mitigate it as much as possible. Now, you can't mitigate the iron, but you can mitigate the sugar. You can mitigate some of the other reactive oxygen species drivers, like, for instance, environmental toxins that are available, okay, like insecticides and things like that, that will cause it as well. All right. Number 3, mitochondrial dysfunction.
Yeah.
Now, remember, we talked about mitochondria being sort of at the heart of this whole problem. Well, it turns out fructose, that sweet molecule in sugar, inhibits 3 separate enzymes that mitochondria need. We've talked about one, CPT1.
And mitochondria basically make energy from the food you're eating and the oxygen you breathe that runs everything in your body. So when that process gets up, you're having an energy crisis.
Exactly right. Exactly right. It inhibits an enzyme called AMP kinase, which is the fuel gauge on the liver cell. It inhibits an enzyme called ACAD-L, acyl-CoA dehydrogenase long chain, which is necessary to get the fatty acids oxidized. So the bottom line is, if your mitochondria are dysfunctional, you're going to be sick. And fructose is a 3-in-1 mitochondrial toxin.
If you love that last video, you're going to love the next one. Check it out here.